Hello, this is Mrs. Decker, and this is Objective 1A on reading and answering questions using a solubility graph. So, before we get started, I want you to think about these two questions. What is a solution, and what are the two parts that make up a solution? So take a second to think about those before we go any further. Okay, so when we're talking about solubility, we're talking about the amount of solute that will dissolve in a specific solvent under given conditions. So the two parts of a solution are the solute, what is being dissolved, and the solvent, what is doing the dissolving. There are several solvents that can be used. For our purposes, the solvent will most likely be water. So a solubility curve will look like this, and it is used to determine the mass of solute in 100 grams or 100 milliliters of water at a given temperature. So if you are looking along the curve is where the compound we're talking about, the solute, is saturated. That means all of the solute that you put into the solvent, into the water, will dissolve, but if you put any more, that will not dissolve. So if we're looking at anything under the saturated line, the solution will be called unsaturated. If we're looking at anything above the saturated line, the solution will be called supersaturated. And I'll show you what that means in just a second. And now you won't be given just the solubility curve for one compound. This is what your graph will look like. You'll have the solubility curves for many compounds at the same time, and you'll need to be able to read and find some information from that graph. Okay, so this is where we're going to use our colored pencils. So pick one color, and then you're going to call that saturated. So we're looking at the solubility curve for NH4Cl. So that is here. So go ahead and take your colored pencil and trace the line all the way across. So this is saturated. And then you want to pick another color for unsaturated. And unsaturated is everything that is under the saturation line. And then the third color for supersaturated, so that would be everything that is above the saturated line. Okay. So for instance, if you are asked, at 50 degrees Celsius, how many grams of NH4Cl can fit in? You can fit in 50 grams. So at 50 degrees Celsius, if you're putting in any less than 50 grams of NH4Cl, it would be unsaturated. If you're putting in any more than 50 grams, it would be considered supersaturated. So here are some of the types of questions you'll be asked. At 60 degrees Celsius, approximately 110 grams of KNO3 will dissolve in 100 grams of water. So here at 60 degrees Celsius, 110 grams is saturated for KNO3. But if the temperature is decreased to 30 degrees Celsius, approximately how many grams of KNO3 will dissolve in 100 grams of water at that temperature? So you want to look at 30 degrees Celsius and go up to the KNO3 line. So it would be about 46 or 47 grams of KNO3 that would dissolve at 30 degrees Celsius. So now we want to find the masses of these different compounds that will dissolve at the specific temperatures. So at 20 degrees Celsius, Ki is all the way up here. So we'll have about 143 grams of Ki that will dissolve at that temperature. NH3 at 70 degrees Celsius would be right here, so about 19 grams. And KClO3 at 50 degrees Celsius. So here is KClO3. So we've got about 22 grams that will dissolve at that temperature. So here are a few more questions for you using the same graph. A solution contains approximately 102 grams of NaNO3 at 40 degrees Celsius. Is it saturated or unsaturated? So we're at 40 degrees Celsius. We want to go up and look at NaNO3, 102 grams. That would be saturated. The next question says a solution contains 80 grams of KNO3 at 60 degrees Celsius. Is it saturated or unsaturated? So here we're at 60 degrees Celsius, go up to 80 grams, so that's where we're at. And the KNO3 line is up here, so that would be unsaturated. So now the next question says how many more grams of KNO3 can dissolve in the solution. So at 60 degrees Celsius, we can dissolve 110 grams of KNO3 in the solution, and if we already have 80, that would mean that 30 more grams can fit into the solution before it becomes saturated. So now that I have gone over how to read the solubility curves, there are 3 pages in your packet to practice. Go ahead and work on those, and then let me know if you need help.